All right, so now we're going to move into chapter 20. And chapter 20 is going to move us into the blood vessels and circulation. One of the things that becomes important when you begin your clinicals and so forth, you're going to be working on measuring blood pressure. We've learned in the last chapter that the heart is the pump that's going to be pushing the blood through the different circuits. The blood vessels are going to actually be the pipes that carry that blood to the tissues and back to the heart. And the blood vessels, they are going to be able to also participate in regulating the blood pressure and helping to direct the blood flow. Our blood vessels and the heart, with the receptors and the areas in the brain, it's regulated so that we can make sure that the blood pressure is sufficient to meet those metabolic needs of the tissues. When we look at the circulatory system, the functions of the circulatory system, we need it to carry blood, exchange the nutrients, pick up waste products, distribute gases. We need it to carry hormones. We need it for the immune system components. We need it for those molecules that'll help with creating the blood clot, regulating blood pressure, directing the blood flow. And so when we begin to think about that cardiac system, the functions of it are very unique, and we're going to see that those blood vessels, the blood vessels that are making up this part of the system, they're going to be termed arteries, capillaries, and veins. When we look at this structure that is formed for these vessels, they are going to be a continuous passageway for the blood flow. Arteries, their job is to carry blood away from the heart. As they move away from the heart, from that really huge aorta, which is going to be elastic tissue, okay, they're going to begin to transition, and they're going to go from that large, that has the really huge amount of the elastic tissue, into smaller arteries, and those are going to become muscular until they reach the smallest portions, which are going to be our arterioles, and we're going to begin to move into them having smooth tissue or smooth muscle. Now, the blood, when we get into the area for the capillaries are where we have the actual exchange of materials. So the blood has to flow into those capillaries, and the capillaries are considered to be the most common type because we have so many of them. And so it's at that capillary where exchange of the nutrients and the waste and the gases and hormones and everything else, it's at the capillary beds where that begins to take place. Once we're in those capillary beds, the arteries meet the veins. So with the veins, they're going to start out having flow in what's their smallest component, which are the venules. They'll move on to be small veins that will move into the medium or the large veins, eventually emptying into the vena cava that are going to lead to the right side of the atria, the right atria on the right side of the heart. The capillaries, their structure is very unique because when we're at the point of the capillaries, we need to make sure that the structure is going to allow for the movement of the materials, and we want to make sure that stuff gets to move out, but stuff also stays in the blood. So what we're going to find in that capillary, we're going to see that it has simple squamous epithelium. Now in the capillaries, that's going to be known as endothelial cells. They're going to also have a basement membrane. They're trying to show you that here in the picture. And we're going to have some connective tissue. They're going to have something called pericapillary cells. Pericapillary means that they are to the outer side of the capillary itself. And you can see it kind of being represented here in this picture. Now, capillaries, once we get to this point, substances are going to move by diffusion. Anything that's going to be lipid soluble, that's going to have the ability to simply move through the plasma membrane of these capillary cells. If something is water soluble, it's going to need a passageway. So we're going to find that this capillary has these gaps. They're known as fenestrae, and it's going to be these gaps that will exist between these endothelial cells, these simple squamous cells, and that's going to allow movement of materials. At the point where the blood actually is in the capillary, the red blood cells, this is the point where they're going to go through single file, and they're going to get squeezed and so forth. And so what's going to happen is that's something you don't want to move out. And so the materials like the oxygen, okay, that the red blood cell's carrying, as that blood cell gets squeezed, the oxygen will be pushed off and get to diffuse into the nearby tissues. The types of capillaries that we have, they're going to be termed continuous, fenestrated, sinusoidal, sinusoids, or venous sinuses. So they're basically classified on what is their diameter and what is their permeability. When we have a continuous capillary, there are no gaps, they're not permeable to large molecules, and we're going to find that these are very numerous in areas such as the muscle, nervous tissue, and other locations throughout the body. The capillaries that are going to be fenestrated, they are going to have pores. This means that those simple squamous, the endothelial cells, have a lot of fenestrae. And so fenestrated, this is where in tissues where the capillaries are very highly permeable, like for example, in the intestines. Basically, we're going to see that having this structure, it allows for the movement of the materials. So if we think about the intestines, well, this is the point that we're going to have absorption of our nutrients and our foodstuffs. So we would want it to have the ability for these materials to move, and therefore giving us these pores that are needed for the movement of those materials. If a capillary has the sinusoids, this is where the fenestrae, the diameter of them, get a little bit larger. We don't have as much basement membrane, and large molecules can readily move across that capillary. The sinusoidal are very common, okay, in liver and bone marrow, where we need to move red blood cells, where we need to move macrophages. So we're going to have in the sinusoids and the sinusoidal, we're going to have them full of these gaps that are going to be present so that larger materials can move through. A venous sinus, that one is similar in structure to the sinusoids, and it's much larger. A good place for this venous sinus is in the spleen, because that's definitely a blood organ, and one of the things that we need to do is get those worn out red blood cells out into the spleen so that we can recycle the material, and the death of the red blood cell can occur. This is showing the structure of these particular capillaries. So if we're looking at one that is continuous, note we don't have any gaps. So the materials are going to have to move across these cells. If we look at the fenestrated, note we begin to see some gaps. In this particular fenestration, there's a membrane that'll be present, but the gap is still pretty large, okay? If we're going to find the fenestrae without a diaphragm, this little membrane that'll be there, this is going to have ability for molecules that can fit through this gap to move. Think about the intestines. This is kind of showing sinusoid and the large fenestrae, stuff that we would find in, for example, the liver and the spleen. Note a very huge gap and a very huge gap right here. That allows for especially the movement of those red blood cells. The capillary network itself, when we begin to look at this capillary bed, one thing I've tried to really point out, in the capillary bed, arteries are going to meet the veins. So what we're going to see is that as we go from something that was really large down to something smaller to the point of the capillary bed, when we get to the blood flow moving into that capillary bed, we're having the blood flow move into this arteriole. Note that we have off of that arteriole something called a met arteriole. It's even smaller than what's already small coming into that capillary network. Now, note the structure, and in this area that we have the arteries have some smooth muscle that is found on these capillaries. Now, if we look at the area for the veins, the structure from an artery to the vein, we're at very small going to very small, but the small for the vein will begin to move into something larger, going to medium veins, going to the large veins, so that we can get the return to the heart. Now, these little smooth muscles, these are called precapillary sphincters. So if you begin to think about what a sphincter does, these smooth muscle sphincters, meaning we do not control it, okay, because it's smooth muscle. This will be the way that the body can control the blood flow into a capillary network. because not every capillary of the body needs to be served with a blood flow all the time, 24/7. The body's going to actually control that.